This diagram shows how signals are transmitted using neurons. Dendrites receive the signal, axons carry the electrical signal, and nerve terminals release the chemical signal. Because electrical signals are converted into chemical signals, these signals are known to be electrochemical. Here, we will focus on how nerve terminals are able to transmit signals to the next neuron. The synapse is the bridge between neurons. It consists of the presynaptic neuron, synaptic cleft, and postsynaptic neuron. The presynaptic neuron is the nerve terminal of the first neuron. It is called presynaptic because it comes before the synaptic cleft. The presynaptic neuron releases neurotransmitters. The synaptic cleft is the space between neurons. This is pretty much where neurotransmitters can float from one neuron to the next. The postsynaptic neuron is the dendrite of the next neuron. It is called postsynaptic because it comes after the synaptic cleft. The postsynaptic neuron receives neurotransmitters that come from the presynaptic neuron. Here are some examples of neurotransmitters. Dopamine gives you feelings of pleasure, satisfaction, and motivation. Junk food releases dopamine, which explains why individuals may seek eating junk food despite it being unhealthy. Serotonin controls your mood. Fluctuations in serotonin may lead to depression and anxiety. Noradrenaline gives feelings of arousal during stress. It is released during a workout to help maintain sufficient energy during an exercise. All of these neurotransmitters are transmitted through neurons, hence the name neurotransmitter. Constant release of a neurotransmitter can lead to adverse effects. For example, too much dopamine may lead to someone becoming more aggressive. Increased dopamine is also linked to schizophrenia. That's why it's important to shut these signals off. There are 3 ways a signal can be regulated so this doesn't happen. The first is using a reuptake carrier. Reuptake carriers bring neurotransmitters that were released into the synaptic cleft back into the presynaptic neuron. Here you can see reuptake carriers decreasing the number of neurotransmitters in the synaptic cleft. Another way is through using an enzyme. Enzymes break down neurotransmitters, which decreases the number of neurotransmitters found in the synaptic cleft. Here, you can see enzymes in the synaptic cleft decreasing the number of neurotransmitters. The last way is through diffusion. Neurotransmitters can simply diffuse their way out of the synaptic cleft and leave. This decreases the number of neurotransmitters the postsynaptic neuron can receive.